Alright, so here we go, 2.8. We want to rewrite equations and formulas. And with equations, what we have to remember is that we always, with an equation, have what in it? An equal sign. Awesome. Always going to have an equal sign. So if we solve for a given variable, we're going through it, hopefully remembering our steps to solving. And I'm not going to take you guys through and have you write all that stuff out. Okay? So what I'm going to have you remember, or at least know through this, is in solving for a given variable, you're going to use all the same rules for solving. So everything that we've talked about in terms of solving, you're going to use all the same rules. So, just like before, our number one rule is to get what? Good. Get the variable by itself. Number two, we're going to perform the what? The inverse operation of what we see. And one of the most important rules was whatever we do to one side, we have to do to the other. Exactly. And then we also talked about sometimes we'll have to put together what? Like terms. We need to put together like terms if we're there. And then we also again talked about sometimes you'll need to use the distributive property. And sometimes maybe we'll have to multiply by a what if we see a fraction? A reciprocal, okay? And then we also talked about that if you have multiple steps, you see addition and subtraction, and you also see multiplication and division, what's performed first? The addition, subtraction, or multiplication, division? DJ? Good. Addition, subtraction occurs before multiplication and division. And then lastly, we worked on one of those today on the board when we went over our homework. If I have a variable on both sides, I need to what? Take the smallest to the largest. So all those rules that we talked about, they're going to remain the same. Well, what's going to change? Michael, question.
What if the variables on both sides are the same?
What if the variables on both sides is the same? Remember, we also dealt with that. If I subtract it from both sides and they would cancel, we're going to be in a situation where either we have no solution or possibly all real numbers. Very good. And we're looking to see if it's a true statement or a false statement. But with this, it's going to be a little bit different. We're going to be solving for a given variable, which means we're going to have to sort through different variables. And I'll show you what I mean. As an example, I have 2x minus 3y is equal to 4, and I'm going to ask you to solve just for y. Two x minus 3y is equal to 4, and again, I'm just going to ask you to solve for y. How is this different? What are you guys seeing right now that's different? Audie? I have two different variables, don't I? So that concept of putting together like terms or maybe taking a smaller variable to a larger variable, you can't do that because the variables are different. So here's the first thing I want you to do with any of these. Whatever variable that you're being asked to solve for, in this case solve for y, I want you to start by writing an arrow right above that variable. So that's the one that you know you've got to get by itself. That keeps you in a constant reminder, this is the one that I want to set my goal, get that variable by itself. Now as we've talked about, if that's what we want to get by itself, that means we got to take everything that's around it and get it over to the other side. So our rules will still apply. What's being done to the variable? Well, if I have a number right next to it, that means it's being what?
Multiplied.
Multiplied. Now, this over here is a positive 2x, and we're subtracting this stuff. But if this is a positive and I want to get it away, I need to what? Subtract it. And we just talked about, we want to take care of the addition and subtraction before the multiplication and division. So what would be my step to get rid of this positive 2x? Subtract it. So I'm going to show the subtraction of 2x right below the positive 2x. And whatever I do to one side, I have to do the other. Well, this is where the tricky part begins. Because if I were to write this, and don't write this in your notes, guys, if I were to write this right below the 4, can I take a 4 and a negative 2x and put those together as like terms? No, you can't. So because they're not like terms, when you go to write it on the other side, write it off to the side to remind yourself that those can't be put together. So just like before, draw your line in, cancel out what cancels, bring down what's left. Very good. Don't forget it's negative. It's very important. Bring down your equal sign, and now bring down exactly what you see. 4 minus 2x. Again, can't put them together. They're not like terms. If you need to, go back and put your arrow over top of the variable. That's the variable I'm trying to get by itself. Follow your rules. Negative 3 is being multiplied, so we need to what? Divide. Whatever I do to one side, I have to. And when I do this, it is being divided by the entire part. Okay? So over here it's easy. These cancel, and I have y by itself. But now what I have to look at is the idea that I'm taking all of this on top divided by one part. And this is something that we're going to talk about. You're going to hear us refer to it as a special type of division. And this is something you won't see in your book, okay? It's something that Miss Seal and I have come up with over the years. It's called heart division. And you guys maybe learned this last year from Miss Seal in pre-algebra. We call it heart division because when we draw in the fact that I'm going to divide 4 by negative 1, or negative 3, and then divide negative 2 by negative 3, it kind of looks like a heart. So it reminds you that with more than one thing on the top divided by a single value, we have to divide these separately. And when I draw in those circles, it looks like this heart. So we have, again, our heart division that we're going to perform. So when you do this, you have 4 divided by negative 3. Can we leave things in terms of fractions? Yes. So 4 divided by negative 3 is negative 4/3. And here you have a negative 2x divided by a negative 3. So first and foremost, negative divided by a negative is a positive. So this becomes an addition, and 2x divided by 3 would just be our 2/3 x. And now, question, do I have y by itself? Yeah. Now, notice guys, what you've been used to doing is when you solve for a variable, you say x equals 2, y equals 7, b equals negative 3. You've always been able